Well, thanks, Gareth, and thanks to the social media network team for inviting me along today. So I've been asked to talk about challenges of new social media for quantitative researchers. Let me say from the outset that I'm not an expert in quantitative research methods, and so if I pose some challenges that we think have come out of our recent work, I'm as interested as anyone else in the answers, and I hope there will be people here who will be able to provide us with some of those answers. What I'm going to do is I'm going to look back at the Reading the Right project, some of the methodological issues that were raised in the course of that project, which was a mixed method project, by the way, using both quantitative and qualitative methods. I'm going to briefly look at how we use computational tools to add useful additional structure to the data set, which allows us to drill down into the interesting parts that we could then apply qualitative methods to. And I'm going to review the issues it raises for quantitative analysis with respect to, for example, issues like sampling, testing the reliability of computational tools, where we use these to try and analyze large amounts of data, and also the question of computational resources and how we can create infrastructures that are able to analyze large amounts of data in reasonable time frames. Just to say that the Reading the Right project was a collaborative effort involving quite a large number of people at various times. The two people I particularly want to highlight today for their contribution are Farida Vis, who was the lead social media researcher on the project, and who will be here later on today, I think. Ah, she's there. And Alexander Voss, who was the lead in the development of the computational tools and infrastructure. So, just a brief note on the methodology. So, I think you may be aware that a lot of work going on developing computational tools to analyze Twitter data. And I'm talking about Twitter today, not about other examples of social media, because that's the data that we've figured in this project. Sentiment analysis, topic analysis, it's a very active area of research. None of the tools that are currently available, I think, can do a job to the degree of precision that as researchers we ideally need. In other words, we don't trust entirely the results that computational methods produce when we look at the sentiment content, or indeed if we try use topic analysis to identify what tweets might be talking about and group similar tweets together. So in our work with the Reading the Right project, we've used computational tools, but we've also worked along in parallel using qualitative methods, which allow us to test the reliability of those tools and use the two methods together in ways that are complementary to their respective strengths. One of the key ideas that we've used, drawing on the work of Gilad Lotan, is the idea of information flows. So this is the way that we have imposed what we think is useful structure on a large volume of tweets, 2.5 million or so, that were collected during the course of the riots in 2011. And what this draws upon is the idea that any collection of tweets can be distinguished between a tweet and its retweets. So there's the idea that there's a source tweet or a parent tweet, and a lot of tweets which are basically retweets of that original one. Since in this project we were interested in how Twitter was used to communicate and share information, we thought that we could use the idea of retweeting as if you like, solid evidence that a tweet has actually been seen and someone has decided that it's useful. So we decided at this point that we would focus our attention on tweets that had been retweeted, and hence on information flows. And any tweets in that corpus which had not been retweeted, we have ignored, on the grounds that we're not even sure that anybody has seen them. They probably have, but we've got no evidence that they actually influence people to act in any particular way. We use computational tools to derive these information flows, to identify parent tweets and their children tweets, and this allowed us then to impose the structure that I mentioned in order to direct our attention to analysing what these information flows were actually about. Well, I mean, in brief, the algorithm for this looks like that. Go through all the tweets and see if it contains the typical signature of a retweet, which begins with RT at so-and-so, username, with then a body, and then calculate the Liebenstein distance between that tweet and a candidate parent tweet. The Liebenstein distance is a number of atomic changes you need to make between one string of text and another string of text. In other words, it's a measure of similarity. It's a very crude measure of similarity because obviously it depends entirely on lexical changes. Character changes are not something more semantically complex and potentially interesting. We set a threshold for this Liebenstein distance at 30 after some experimentation. And so if any tweet was within that threshold of a parent tweet, we decided it was part of that information flow. And that comparison was repeated over the whole corpus. This algorithm is basically sort of n squared in complexity. So you can see how the time it takes to compute all this rapidly grows with the size of the data set. And that's an issue, of course, that we need to take very seriously when we consider how to apply this technique on perhaps larger corpuses than we had in this occasion. In fact, the reading the rights corpus, though it may seem as if it's large, 2.5 million, it's actually not that big compared with other corpora that one might collect. So having applied this, we're able to derive information flows, of which some examples can be seen on this slide. And at the end of each of those, you'll see the small number, which is the size of that information flow. So what we get from doing this information flow analysis is it allows us to rank information flows by size. That comes out very directly from this analysis. And using that as a heuristic about what's interesting, about what has been most, shall we say, important in this corpus in terms of understanding what people have been talking about and how information has flowed through the community, we can look at information flows, we can rank them by size, and we can use that ranking as a heuristic for directing our subsequent qualitative analysis, where we look to see what these information flows actually seem to be about. So we can see an information flow, the first one is of about 750 tweets, tweet and its retweets. One down here towards the bottom left is nearly 7,500, so 10 times the size, in fact one of the biggest in the whole corpus. Now, just to briefly mention then also the qualitative side of this was the developing of coding frames, which Farida, as I mentioned, was a lead social media researcher on. And this was done in the established way of inductively deriving topics by looking at the content of these information flows and categorizing them appropriately according to the questions that we were looking to answer. So this is an example of coding frames that we've used that show how We've identified different types of tweets by, for example, whether they're media reports or not, whether they contain pictures. One of interest here, particularly for today's presentation, is whether a tweet relates to what we refer to as a rumor. William mentioned earlier how he had spent a sleepless night wondering if rumor about something happening in the East End was true. Well, maybe be able to give an example of Twitter in the context of that particular issue, and so forth. And we have expanded on these coding frames in order to capture the kinds of the typology that's relevant to the questions we're answering. So, turning to rumors on Twitter, in this corpus, we were asked to look particularly at a number of rumors that were known to have been circulating during the course of the August riots, and were suspected to be present, therefore, in the corpus. These range from the fact that it was claimed that rioters had set animals free from London Zoo, which, if you live in Primrose Hill, might have kept you awake. That the army was assembling in Bank for some riot-related purpose, that rioters had attacked the Children's Hospital in Birmingham, that the London Eye had been set on fire. What we wanted to do here was to look at the life cycle, the life history of these rumours, to see what happened from the time that they first materialise in the corpus to eventually when they disappear. And this is work we did with The Guardian, and this is the visualisation that we came up in conjunction with their interactive team, which shows the example, in this case, of rioters attacking a children's hospital in Birmingham. So the bubbles reflect, the size reflects the number of tweets in an information flow associated with this rumour. The colour coding reflects whether a particular information flow has been identified supporting a rumour in green. If it's challenging a rumour, it's in red. If it's a comment, it's in this grey. And if it's querying and asking for information, it's in yellow. So if we just step through this, we see this immediate burst of information flows basically talking about this rumour, saying that this is happening, that rioters have been attacking Children's Hospital. After a while, we begin to see some dissenting voices emerge, as shown by the red bubbles. People asking, querying, and so on. The dissenters beginning to dominate, and eventually, after a while, the whole rumour it draws to a close, it disappears from the corpus as a topic. Now, this is interesting because it helps to sort of understand how people react when rumours are abroad, how people pick them up, how they repeat them, how some people ask questions about them and are not convinced, and how others eventually come in and provide challenges to those claims. And it's interesting that, as William said when he was looking on Twitter for that, to see whether there's information about what we perceived to be going on in East London the other night, that nothing was happening in the mainstream media. The same thing we find in these case studies as well. And what we can conclude from that is, rumours break very quickly in social media. Mainstream media is rather late to get into this process. And there's questions here about whether they're therefore monitoring what's happening in social media effectively enough. I mean, you might say, well, why does it matter? Well, it might matter because people, not least, are maybe kept awake and anxious about what they believe to be happening, and they may make decisions based upon information that turns out to be incorrect. Okay, so I just want to move on now to look at some related work with this corpus, which is a sentiment analysis that we did in collaboration with Mike Thelwall, who I think has not yet arrived, but will be here later. We tried doing some sentiment analysis of this data. So the top graph shows the overall volume of tweets over a period of time in the corpus. And then in the bottom graph, we have a series of graphs which show sentiment levels as determined by automatic analysis using Mike's Senti strength tool. And so just to get this, make sure I get this correct, the thick red line is the average sentiment of positive sentiment, average strength of positive sentiment in tweets. So you can see that there. And the value of this would vary between 0 and plus and 2. Negative tweets is the thick black line. So you can see that more negative sentiment than positive sentiment in this particular case. The thin red line is the average strength of positive sentiment in subjective tweets. In other words, there's a threshold here above what we consider tweets to be reliably subjective. And we can see that this gives a slightly different picture of what is positive and what is negative in terms of sentiment. Okay, so this is potentially useful, being able to do this. But the question we have to ask ourselves is how reliable are the results that such analysis can produce. We can see how we can extract positive and negative sentiment. We can measure how strong it is. But how much confidence can we put in those results as an interpretation of this data? It's undeniably the case that with larger volumes of data, we need these sorts of tools to help us, because we can't do all this work by hand, but we need to have confidence in that data. And I'll come in those results. I need to come back to that in a moment. What I'll look at first, though, is a number of sampling issues. First of all, in connection with that particular corpus itself, the corpus was collected on our behalf. We had no direct involvement in that. It was done, in fact, before we got involved with The Guardian. But what they used was a set of hashtags which they generated by looking at Twitter feeds and sort of snowballing, if you like, looking at some initial hashtags and then seeing what other hashtags were appearing alongside them. And they eventually came up with about 140, I think, hashtags, which they then used to collect the whole corpus. Now, of course, that means that we haven't got access to all tweets that might be relevant to this particular study. There may well be tweets that are relevant but are missing because they don't happen to have the hashtags that we used. So there's a systematic exclusion of some data. We're not in a position to say how relevant that data is, but we have to admit that it may be possible. Also, of course, we haven't collected what's called direct messages, which are private between Twitter users. We've only collected the public ones. So again, there might be interesting content there which we don't have access to. Secondly, Twitter users, as I suspect anybody who's thought about using it for survey purposes, are not representative of the population as a whole. They're younger, better off, better educated and urban. And so the questions here about whether that kind of inbuilt bias can be countered in some way, perhaps by making use of the information that people make available in their profiles. But that's not perfect by any means, because it's entirely up to people's own choices, what they put in their profiles. There's nothing there that one can categorically say would enable you to identify unambiguously, for survey purposes, somebody's demographic. Secondly, if you're thinking about collecting Twitter data now or in the future, it's well to note some of the features of the Twitter data APIs. Unless, of course, you happen to be fortunate enough to be able to pay the two providers of Twitter data, that's DataSift and GNIP, who for a small fortune in academic terms will provide you with whatever data you want. And I'm talking about a small fortune, it's several $1,000s a month, which for academics I think is probably far more than we can afford. We have to make use of the APIs that Twitter has made available, and these have different characteristics when it comes to considering what kind of data you can actually collect in terms of the timescale you can collect tweets over, whether you can do it in real time, if you're interested in that kind of work, if you want to do it retrospectiveness, in terms of completeness. In other words, can you guarantee you'll get all the data that you would like to have about a particular topic, and the functionality that allows you to specify some subset of a particular of the Twitter stream. Now, I don't want to go overboard in the technical details here, but just to summarize that 3 different APIs, if you like. One is called the Search API, which allows for an unauthenticated use, so you can do it from an anonymous account. This allows you to search by keyword, by account on the Twitter stream. You can't get any tweets older than about a week, so if you're interested in data that goes back some time, that's not going to be any use to you. And you're rate limited. In other words, you can't get more than a certain proportion of the Twitter stream through that API. The important point, I think, for researchers here is you don't know how that rate limiting works, so you don't know what you're missing. There is another API which is called the REST API, which you use from an authenticated account, and it's account-centric in the ways it allows you to harvest against the Twitter stream. So you can retrieve tweets, profile data of individual accounts, the friends and followers of individual users, and you can also get their direct messages. You can search public tweets as well, and that's rate limited to 350 requests per hour. If you exceed that, then you will be stopped, and you'll have to wait and come back and restart. So again, there are very important issues about how that affects, if you're trying to collect against a sampling frame, your sampling frame may be in trouble. You may not be able to guarantee that you've collected adequately against it. Also, users can delete tweets, so some may become inaccessible, either of these APIs you use. Twitter can retire tweets as well. Over a period of time, tweets will disappear. It depends on basically how active somebody is. If they're very active, then their old tweets will disappear pretty quickly. And as I say, rate limiting means it's difficult to collect substantial corpora that you can guarantee are complete in some sense. Finally, there's a Twitter streaming API, which allows to collect against a random sample set by keyword, which allows you to track tweets, following accounts, or by geolocation. But note that few tweets are geolocated. And both track and follow are rate limited again. But the advantage here is that this is done, so Twitter says, in such a way as you're still guaranteed a random sample. So if that is a factor in the design of your sampling frame, then that may well give you confidence that although you're not getting all the tweets, you are nevertheless getting a sample that is appropriate and adequate for any analysis you want to do. I say that's what they say. I don't think we have absolute confidence that that is the case. It would bear some testing, I think, to secure that. Finally, then, turning back to the question of reliability of computer-based tools to assist with the analysis, and remembering the sentiment analysis that we were doing, we employed people to code information flows, to code them for topic, also to code them, in other words, to code, in this case, about a tweet, whether it was a claim or a counterclaim of a rumor. So we had human effort for small subsets of that corpora. We obviously didn't do it for the whole corpus, We wouldn't have had the time to do it. But human coders provide, if you like, a gold standard to compare and evaluate the performance of computer-based analysis. And this particular graphic, which is due to Mike, who I see has arrived now, was comparing the predictions of the sentence strength tool, which I showed you some results from before, with the judgment of human coders. This actually is for a different data set, which we collected during the time of the alternative vote referendum. And you can see that in the center, in the green area, we have a good match between human coders and the sentence strength judgment. As we look at the rest of the graphic, we can see that we get differences in opinion growing in scale, such that sometimes at the outer edges there's quite a lot of disagreement. But there is nevertheless within the central area, which is where the agreement is best, a reasonably good proportion of agreement. What we're doing here is we're evaluating the reliability, if you like, of this, the analysis of this content. We're able here, because we used these are results from a smaller corpus, to actually code all the corpus, and therefore we could say that the measure of agreement between sentence strength and this corpus is such and such. If we were doing this again over the whole riot corpus, which we couldn't do the coding of the whole corpus, we would have to consider what statement we can make about the reliability of sentence strength based upon looking at only a small subset of that corpus. So this is the question, I think, which for those who are expert in sampling frame design and statistical methods that I'm interested in. If you have a given corpus sample and you know that a computer-based tool matches that performance of human coders with a precision of a certain percentage, what is the estimated precision over the whole corpus? If you wanted to extrapolate that result over the whole corpus, what precision values would you come up, and what confidence intervals would you put to that figure? And then again, if you're going to take a subsample to do human coding on, how do you design the subsample? You just take a random set of tweets, or do you have to take into account who's tweeting it? So you get a random sample of tweeters. Do you want to factor in other parameters of the corpus, like the hashtags used, and so on and so forth? I think in natural language processing benchmarking generally, the design of corpus benchmarks is quite a complex issue. And I think similar issues will have to be considered if we're trying to extract representative samples from large corpora, which we can use to benchmark the performance of tools. We have to be very careful in how we construct that sampling frame. A final note about computational infrastructure. You can get a huge number of tweets flowing at any given time. This is, I think, shows how the volume of tweets increased. I think it was during the time that it was known that bin Laden had been killed. You can see how the volume rose very significantly over this time. And one can get, we know from Twitter figures that there's looking at perhaps 140 million tweets a day. This is, to handle that kind of data, even to harvest it against the APIs that we've seen, requires quite able computational infrastructure that can be quickly scaled to deal with the volume of tweets that you're interested in. And we're turning to cloud computing as a solution here because it's more flexible and easily scalable with the changing demand that harvesting and processing might raise for the computational side of any project that we want to conduct in the future. So that's it. Happy to answer any questions to the best of my ability. But as I say, I think I'm here as much to learn from some of the experts in quantitative methods about how we can tackle some of the issues that I've raised. So thank you.
We've got about 5-10 minutes for questions for Rob, and I think there's a mic that might be overdoing it slightly. So if you can stand up and say where you're from.
Yeah. I'm Hazel Hall, I'm from Edinburgh University. I've got a little story and then I've got a question, and the story is related to hearing the sirens going off. Oh, okay, right. Okay, so I've got a story about... Is that switched on? Yes. Like the sirens going off story we heard earlier on. I had an undergraduate student who did a really small-scale study. He was looking at the use of Twitter by emergency services. And he interviewed the press officer of a fire service who said that one of the difficulties they've got is the way that the information has to reach them before they respond to an emergency. And I think that will tie into how the information then reaches the media. And this particular press officer was at home on a Sunday night, could see a fire outside her bedroom window. She could see the smoke coming up. She could see other people going to look at the fire. She went on Twitter. She could see people talking about it. There wasn't a single fire engine there because the fire service would not take calls over Twitter. They have to still come in through the telephone system, which is just an interesting story which ties up the earlier thing. But my question for you is about, you made the comment that we can only guarantee that a tweet has been read if it's been retweeted. But did you take into account that I believe that tweets can be retweeted by robots? So there could be some automatic tweeting by a system which isn't a human being. And that kind of hits some of the sampling issues you were talking about. I don't know if you compensated for that in the study or whether you made sure that you would... I mean, I don't know how you can check that they're real humans doing the retweeting.
I think it's difficult without looking at the accounts from which that retweeting has come. So I think it's an interesting point and one that people should be aware of. How one can do that practically, I think, is a challenge because it raises potentially a question about looking at a large number of accounts. In the work we did that was led by Farida to profile the accounts that were in that corpus, what we did was in the end to look at the actor types for the top 200 of accounts. In other words, the ones that had the top 200 in terms of mentions. Of course, mentions automatically happen when you retweet. So within those top 200, we know that we suspect, I think there are no robotic accounts. Farida can, I think, probably confirm that. There may be, indeed, as you say, robot accounts in that corpus. But actually ensuring that everyone is identified is a very big challenge, I think. And we may have to look and see if by harvesting account profiles, one can begin to automate that to some degree. That's not something we've tried to do yet.
I think it's just another thing to add to the list of sampling issues.
Yes, it is. Indeed, it is. Yes, yeah. I mean, there's a whole lot of issues about account and sampling. If you're looking to do a survey, if you want a representative sample demographically, if you want to exclude tweets that come from people who are not even in the geographical region that you're interested in. And it's not easy to be able to establish, I think, with complete confidence from profile information whether someone should be included, an account should be included or excluded from your sample. There are various proxies like language, like time zone, and so on and so forth, which might help to establish, for example, geographical relevance. But again, that's still, I think, far from perfect. And then, there's a lot of other demographic dimensions that I think are relevant to survey work, which, you simply won't get from looking at account profiles.
Any other questions?
Mariangela Ferrario from Computing, Lancaster University. Curiosity, Have you done any analysis of the difference of stickiness between rumors?
I'm sorry, I can't quite hear that.
Stickiness between the different rumors that spread during the riots, like say in terms of geographic spread, time, and even like the scope, the number of people that retweeted. Have you done any statistical comparison and identification why some rumors stick more than others?
We haven't done that kind of analysis on the rumour subcorpora, no. I mean, we've identified by looking at them, comparing them, that they seem to follow a very similar trajectory. You mentioned looking at location. Well, again, that's a problem because one can't always guarantee where someone is when they send a tweet for the reasons that I've explained. So that's a very difficult thing to do. I think we might, if we do some more work in looking at the rumours and how they propagated, we might look at some of the questions that you raised. We might look and see how, whether there's overlaps between those involved in the propagation of some of those rumours. I think probably not, because they're actually quite geographically spread, not just London-based, for example, Manchester, Birmingham, and so forth. But so yeah, I mean, those are all potentially interesting questions to consider in trying to understand the trajectory of rumours and how one explains the characteristics and what we can make of them over the life cycle. I think what we do is identify, as I said, that mainstream media and authoritative sources of information are late to get involved, and that seems to perhaps account for persistence of some of these rumours. We also note, and I think William mentioned about mischievous use of Twitter in this respect, we also find that people quite deliberately try to convince others of something they know to be false, because they Photoshop, for example, pictures that purport to show something's happening like London Eye on fire, which, the photo they proffer to support that claim turns out to be, one that's been edited in order to create that impression. So, there's a lot of interesting things yet to look at in terms of the rumours, why people get involved, and so forth. Yeah.
Okay, I'm conscious of the time, and I'm sure there's lots more questions we have for Rob and on those issues, but we'll hopefully pick those up in the workshop sessions this afternoon. So, thank you very much.
Okay.